Hey, last video, I'm going to try to make this one a little bit shorter than the last two. The last two got a little long-winded. So we are going to convert standard form into slope-intercept form and vice versa. We're going to go back and forth between the two. I might as well start with our basic standard form equation so we can see how standard form and slope-intercept form sort of relate in terms of slope and y-intercept. So I'm going to just do some of the basic algebra steps that I'm used to doing. So I'm going to subtract ax from both sides. I get by is equal to negative ax plus c. I'm putting the ax in front so that way I can truly have it in that y equals mx plus b form when I'm finished. I'm going to divide by b on all the terms because you know that we have to, when we multiply or divide, we have to hit all the terms. Otherwise, we're changing the proportionality of the problem, which we've played around with a bit. So then my slope is essentially made up of a ratio between negative AB x plus our constant is made up of, or our y-intercept of is made up of c divided by b. Kind of interesting. So slope-intercept form, y equals mx plus b. If I know what my a and b value are, if I negate those and put them over the top, I can figure out what my slope is. If I know what my c and my b are, I can put them over the top and I get my b. So let's look at this. We have 3x minus 2y is equal to 6. If I'm going to follow this format of that, I can sort of predict what my equation is going to look like. Now I'm going to actually convert this into slope-intercept form using the same sort of algebraic knowledge like that we showed over here. But let's also sort of skip to the chase and see what it would look like if I used this format. So we have y, and I'm putting it way down here so that way I can do the algebra underneath. I need a over b, so 3 over negative 2, and I need negative a over b, so I need to convert that to a positive number. So 3 over a negative 2, negative 3 over negative 2 equals 3/2 x plus c over b, which is 6 over negative 2. So 6 divided by a negative 2 is negative 3. So this is what I should end up getting after I finish this actual conversion. So now let's do the math work. I'm going to subtract 3x from both sides. Negative 2y is equal to negative 3x plus 6. Essentially what I'm doing is I'm just solving to get y by itself because that's what when your slope-intercept form is all about. It's just trying to get that y all by itself. So we get y is equal to negative 3 over negative 2, which is 3/2 x, which is exactly what we had before over here. And then we have 6 divided by a negative 2, which is negative 3, which is the same as this plus a negative 3. Got the same thing. Kind of sweet. Awesome. Now, what if I was given a slope-intercept form equation and I wanted to turn it into a standard form equation? Let's do that. So here is an example of a problem that I think is worthy of our attention. We have y equals negative 1/2 x plus 3/4. We are going to turn this into standard form. I would want to turn this into standard form and graph it via standard form because we have a lot of fractions in here and I can't accurately graph this unless I use a graphing calculator or something like that. So instead of actually using a graphing calculator to graph this, let's see if we can convert it into standard form and actually use intercepts or something like that to graph this a little bit easier. First things first, I want to get rid of these fractions because we know in standard form we can't have fractions. So I'm going to multiply by the greatest common denominator. So we have 2 and 4. If I multiplied by 4 here, I'd get rid of this 4. If I multiplied by 4 here, I also would get rid of that 2. If I multiplied by 2 on both of them, I wouldn't take care of this problem over here. So I'm going to multiply by 4. By 4 over 1 on every single term. By 4 over 1, by 4 over 1. 4 over 1 times y equals 4y, which is equal to 4 times negative 1/2, which is negative 2x. And then here, our 4's can simplify and we get 3. Now I want to get this x over to this other side because our standard form equation, ax plus by equals c, calls for our constant. In this situation, is going to be 3 to be all by itself. So I need to add 2x to both sides to get both of the variables on one side. So we get 2x plus 4y is equal to 3. And if I look at this, this is definitely a whole lot easier for me to find intercepts. Now, are they going to be pretty? No, they're going to be really messy. Because if I said y is equal to 0, I have x is equal to 3 halves. If I had x equal to 0, y is going to equal 3/4. But at least it's a little prettier to look at, right? That's the point, right? Yeah, that's the point. All right, so now I want you to practice the must-do practice problems. Take the exit pass, have a blast, show your knowledge. Let me know if you have any questions, okay? As always. Bye.